Section 1.8, Part 2, Composition of Functions. Now we're going to look at the composition of two functions. So yesterday we did addition, subtraction, multiplication, division, and now we're going to be looking at the last operation, which is a unique operation that can only be done with functions. This is composition. So the notation's done a couple different ways. So one of the ways kind of looks like this, where we have this sort of f little circle g, right, of x. That's pretty common. The other one looks like this. Now, in my opinion, I prefer the red notation. And the reason I like the red notation just a little bit better is because you really physically understand what composition is. It's the idea that instead of just plugging a number into a function, we're plugging a function into a function. So we're going to take whatever g of x is and literally replace all the inputs or all the x's of f with that expression that g of x is. So I like this better because, like I said, it really illustrates well, what is actually going on, but this is another kind of common way to write it. So while this is obvious what's on the inside and outside, in this style notation here, remember g, the second thing, is in the first thing. So like f, the first thing that's written is the main idea, and into that we're plugging g. Okay, so when it's written in this little open circle notation, the first one is the big idea, the second one is what's going into it. Now, the other kind of trickier thing about this is that when you want to consider the domain of a composition, it's not simply looking at, f and g and figuring out where they overlap. It's actually similar, but a little different, because what you're going to do is look at the domain of the inside function. So in this case, the g, or the second one here, you look at the domain of the g, and then you ask yourself, okay, after I do the composition and simplify it and get all the way done, what would the domain of that be? And then whatever the overlap of those two things are, okay, of the inside function and the final result, that's the domain of the overall composition. Okay, so basically you got to kind of finish it first and then take a look at it. So before we begin, since we're dealing with our example here of f and g is going to be on the inside for some of these, and f's going to be on the inside for some of these. So I just want to kind of quickly above them write where their domains are. So for f of x, right, this is x to the third. Well, that's just a polynomial, so its domain is all real numbers. For g of x, it's 1 over x, and that means its domain is everything except 0, because obviously you can't divide by 0. So the domain is going to be from negative infinity all the way up to 0, non-inclusive, union with 0, non-inclusive, all the way to positive infinity. Okay, so I just want to make a note of that, so that way when I try these compositions, it's going to be easy for me to go ahead and figure out what that domain is going to be. Okay, so for our first one, we're doing f of g of x. So that means I'm going to take g, so in this case the 1 over x, and put it into all the x's of f. So this 1 over x goes in place of this. Now when I write it, I like to go ahead and basically write down f of x and just replace the x's with parentheses. Now f of x is simply x cubed. So if I want to write f with parentheses instead of x's, it looks like this. That's it. Then once you've written the outside main function, with parentheses instead of x's, inside those parentheses, you're going to copy down g. So in this case, the function g is 1 over x. Okay, so here's my g, and it replaced the x in f of x, right, because that was the input. So I'm going to take whatever g is and cube it. So when I simplify this, really there's not too much to it. It's just going to be basically, 1 over x times 1 over x times 1 over x, so that would just be 1 over x cubed. Now, when we want to discuss the denominator, here's the deal. The inside basically is all numbers except 0. The overall function, the final answer, is actually the same thing, because when you look at the final result here in black, again, there's an x in the denominator, so you really can't have 0 as your denominator. So that means the thing, what they share in common really is from negative infinity to positive infinity, but not including 0. So the domain is going to be the same. So negative infinity, not including 0, and then after 0 to positive infinity. Because again, what we're looking at is the red and the black. Okay, you look at the domain of the inside part, and then you look at the domain of the result when it's all done, and figure out what they share in common. And again, both of these share in common that it can be anything, just not 0. Now let's flip it around and do it the other way. Okay, so this time g is the main function, and f is going to go on the inside. So in this case, again, we're going to write 1 over parentheses, because I always like to write whatever the outside function is with parentheses where the x was. Okay, so 1 over parentheses in place of this x. And let's put f inside of that. So this time it's going to look like x cubed inside of it. And again, when we simplify this one, it actually ends up looking the same, right? You get 1 over x cubed. Now, the difference in this, however, is the inside function, the blue, right, the f, right, that has an all real number domain from negative infinity to infinity. But the final result cannot include 0. So you have to ask yourself where they overlap. Well, if one of them is all real numbers and the other one is all real numbers, just not 0, what they share in common is, all real numbers, just not 0. So again, the domain on this one's going to go from negative infinity up to 0, and then union after 0 to infinity. Now, our last example is going to be a unique situation where we're actually going to compose a function with itself. So this is f of x. And that just means that we're going to take the function f and put whatever f is inside of that. So on the outside, right, because f of x is x cubed, we're just going to say that's, something being cubed. And what we're going to put inside of it is, again, f, which is, x cubed. So if we simplify, we get x to the third, which is going to be x raised to the 9th power. And on this one, again, the inside function is x cubed, whose domain is all real numbers. And looking at the result, x to the 9th, that's also all real numbers because they're both polynomial. So what they share in common, of course, is all real numbers. So the domain here would be from negative infinity to positive infinity. Okay, let's try one more example, but this time with a little more interesting functions, right? Not just linears and stuff. Let's put a radical in there, okay? So for the first one, we're going to find f of g, and I just realized we got to get some parentheses in there, so let's put some parentheses there. Okay, so we're going to do f of g of x, and we're going to figure out what that looks like and identify the domain. Okay, so let's just do it first, okay? So I'm going to use blue, right, for f of x, and I'm going to use red for g of x. So when I want to find this whole thing, so this is, f of g of x, we're going to start with our outside function. F is the outside function. So that means it's going to be the input squared minus 4. Okay, remember, I like to write the main outside function using parentheses in place of the x, because that is where we're going to plug in the g. So let's take this square root of x minus 3, what g is, and put it in here. Awesome. Now all we have to do is simplify. Now, if we take the square root of x minus 3 and square it, that's just going to give us x minus 3, right? Straight up. And then minus 4. And when you put all that together, we get x minus 7. Now, again, the big challenge is going to be looking at the domain. So let's consider what these domains look like. The domain of f, okay, so that one right there, really doesn't play a big role because all I care about, remember, is the inside function, right? The one that's in red, so g, and the final result. Those are the two domains I have to consider. So if I look at the domain of g, remember this is a radical. So whatever I plug under the radical can never be negative. You can be 0, you can be positive, you just can't be negative. So you have to ask yourself, what would make that the case? Well, that means whatever's in there, in this case x minus 3, it has to be greater than or equal to 0. So if you solve that inequality, it's saying x must be greater than or equal to 3. Okay, and as far as like in interval notation, that would just be, from and including, I should use brackets here, 3 to positive infinity. Okay, that's what you're allowed to do in G. Now, in our final result, what's the domain of that? Well, this is just x minus 7, a nice polynomial. So that's going to have a domain of all real numbers. So when I want to figure out the domain of the entire composition, I have to go over here and say, okay, what do these two share in common? Well, this one is 3 to infinity. This one is all numbers. So the overlap, what they share in common, is going to be from positive 3 to positive infinity. So the domain of this one is going to be the positive 3 to positive infinity.